Hello everybody, welcome back to Vitrolife Academy Studio. I'm going to do a presentation on our demonstration on how to do vitrification using our closed system, the Rapid Eye Vitrification Kit. Now there's three parts to the vitrification that I would like to demonstrate to you. First of all is the actual smart box, the reservoir in which we will contain the liquid nitrogen. It has some nice features. It's designed ergonomically, so when you hold it on the handles, it's easy to pour liquid nitrogen out of it and also to fill it up. We also have a specialized lid that goes on top of the box that can contain the nitrogen vapor so that there's not too much evaporation that can then make you lose the liquid nitrogen. Inside the dish, inside the box as well, we have a special container which will help you to handle the straws. For instance, there's specific segments here that can hold individual straws with built-in magnets on the inside that will prevent the straws from falling out. So it just makes handling overall a lot easier. With regards to the actual vitrification device, we have the straws individually packed like this. And inside the package, when you open it up, you have the straw itself, and you also have the Rapid Eye. And the Rapid Eye is the device on which you will eventually load the embryo for vitrification. Now, a little bit more about the straw. You will see when you open it up, there is a small metal piece at the bottom which is sealed inside the straw. And this metal piece is what will give the straw a bit of weight when you place it inside the cane so it doesn't float up in your liquid nitrogen storage tank. There's also a metal rod inside the straw, and this metal rod is very important to prevent the straw from bending and kinking, because eventually we will place the Rapid Eye inside the straw and we want to make sure that it can go in and that there's no bends and kinks to it. The straw itself is then also labeled with warning lines of the bottom level of liquid nitrogen. I'd also have color coding to easily identify the straws when you have to label it for the patients. Another important aspect of the metal rod is we have to place it inside during the cooling effect. So our smart box will be filled with nitrogen and we place the straw inside the box. If the metal rod was not inside, what would happen is that the water vapor in the air will form condensation on the inside of the straw, and that's something we want to prevent. So by keeping the rod inside up until the point of vitrification is very important, so that you only remove it and do the vitrification straight away. It's a closed system, so as I've demonstrated to you before, the one side is already closed, you don't need to close it, and the other side is open. So after you've inserted the Rapid Eye, you will then be able to seal it with a ultrasonic sealer. It's designed with a mouthpiece to fit exactly over the top of the straw, and then you'll be able to seal it. But I will demonstrate that to you in just a second. One of the key features here is the fact that your embryo is actually never in contact with liquid nitrogen. It's vitrified in pre-cooled air, so the whole column of air inside that straw is being cooled down to minus 196 degrees, and vitrification takes place instantly as soon as you place the Rapid Eye with the embryos inside that cooled air. Now a little bit about our vitrification media. We have stage-specific kits for oocytes, blastocysts, cleavage stage embryos, but we also have a kit for all stages of development called Omni. The cryoprotectants are the same in these three kits. So we have sucrose, and we have propanediol and ethylene glycol as the penetrating cryoprotectants. One of the unique components of our media is also hyaluronan, because we know that hyaluronan has a very protective effect during these stages of very low temperatures. So that's unique to our kits as well. And then the addition of GMOPs inside, or a MOPS buffer inside the kits, is also very important in order to maintain the pH at the correct level while you're working outside of the incubator. Our kits are designed to work at 37 degrees Celsius. We believe it's a more physiological temperature to work at. And as you would know, the metabolism and metabolic processes also happen faster at a higher temperature. So the timings of our protocol is also designed with this in mind. The cryoprotectants, the amount of exposure of the cryoprotectants to the cells, and the temperature that we will keep them at. So follow these protocols exactly as they were written, practice them to make sure that you give your patients the best possible chance for a good outcome when you do vitrification. In brief, the protocol is actually very simple. We have a 3-step process. In the first solution for vitrification, it's kind of an equilibration medium, and a lot of clinics nowadays do vitrification only for blastocysts. So this is an ideal timing to collapse your blastocysts, because we've seen that there's a lot of results showing better survival of your embryos, of your blastocysts, when you do collapsing of the blastocysts. So that first solution, you have a minimum of 5 minutes that you can keep them in there and do all these type of collapsing, artificial collapsing in there. The second solution is marked at 2 minutes if we work with blastocysts. If you follow the other kits, for instance, working with oocytes or cleavage stage embryos, you need to validate and follow the protocol for that specific timing. And then once you're done with the 2 minutes in the second solution, you will place them in the third solution. Now the third solution, we also create, I can just mention, we prefer to use these 5-well dishes from Vitrolife because they have direct contact with your heated stage, and therefore they transfer the temperature much better to your culture media, and therefore you are able to maintain that 37 degrees Celsius much better. So you have solution 1 in the first well, solution 2 in the second well, and solution 3 in the third well. However, at the third step, you don't move your embryos into the third well. We make use of a 60 millimeter dish in which you will create 2 droplets of 50 microliters of solution 3, Vitri 3. So we wash our embryos in the first drop, make sure you have very little carryover, and rinse your pipette properly before you pick it up again. And that way we ensure that we don't dilute these droplets, and especially this very critical third solution with a high concentration of cryoprotectants. And after it's been rinsed in the second droplet, you will be ready to load it on top of your rapid eye. And I want to now explain a little bit more about the rapid eye. Maybe not that easy for you to visualize there, but when you see the package, one of the edges are marked with a black dot and the other side is colorless. And it's this colorless side where we will actually load the embryos on. Now I'm going to ask the camera to pan a bit here on the screen, and you'll be able to see the rapid eye on the screen. We have the circle in the middle is the space where we will actually load the embryo. Now it's not hollow, the hole goes straight through the rapid eye. And this means that the embryos are held in position by surface tension. It's an extremely small hole. The volume there is only about 30 nanoliters. And as long as everybody fill the hole, you will all load exactly the same amount of volume, and therefore you will be able to get much more consistent results. Because the hole is that small, the surface tension is actually really, really strong, and therefore there's no possibility of the embryo that can actually fall out of the hole. So that's what you aim for, to fill the hole completely. Be careful not to overfill the hole. I get the question quite often, if I fill too much media, can I suck the medium off again? Yes, you can, but I would advise you to practice a bit more, that you only fill the correct amount of medium in the hole. That will take some risk away that you could potentially pull the embryo off the device when you actually do the when you fill the rapid eye with the embryo. So once you've filled the hole with the rapid eye in the embryo, you will remove the straw, the metal rod from the straw, and you will place the rapid eye inside. So I'm going to go through the steps on the microscope. You will be able to see the glass beads that I'll be working with today, and I'll go through the motions. So at this point, I've already introduced my embryos to the first solution, and you'll be able to see them there as little red dots on the screen. So now I'm going to prime my pipette with the second solution. I will pick up my embryo. In this case, I'm just going to pick up one, with as little as possible medium, transfer it to solution 2. If you find at this point that the embryo floats to the top of the surface, pick it up again and just place it back down on the bottom. And this is quite normal. This is quite normal because the concentration of cryoprotectants are very different between the solutions, and that's why they will float to the top. So just pick it from the top and put it back down on the bottom again. Now we remain there for 2 minutes, and during that 2 minutes I will make sure that my straw is in place, and when I have about 10 or 15 seconds left, I'm going to produce 2 50 microliter droplets from the third solution. Okay, so I've got 10 seconds left, so I'm going to take media from my third solution and I'll be creating 2 droplets here. Of my third solution. So at this point we have now reached the 2 minutes in the second solution, and once again I will rinse my pipette first. And then pick up my embryo with as little as possible media from the second solution and place it directly into the first droplet. As soon as in the droplet, I discard the remaining media so that I don't dilute the concentration of the cryoprotectants. I will rinse my pipette again, rinse my embryo, move it into the second droplet, and again discard the remaining media to not dilute the concentration. And at this point I'm ready to load my rapid eye. So hopefully you'll be able to see that on the screen. I'm going to pick up my embryo with as little as possible media. And place it inside the hole. And at this point we've loaded. I can remove the metal rod and drop my rapid eye inside, and the vitrification is complete. We have in this way ensured that our system has stayed closed. The embryo has never been in contact with liquid nitrogen, and we have now a system that we can seal afterwards. So we make use of the ultrasonic sealer, hold it over the top and make sure it's switched on. And then it takes about 4 or 5 seconds to seal the device. And in this way, it also makes it very easy for the embryologist. There's no stress because the vitrification takes place immediately. It's all incorporated into your smart box, so the handling is very easy. The straw is being kept upright, and it just makes handling a lot easier. Of course, you need to make sure that your smart box is always filled up to a high enough level so that your embryo is never exposed above the level of liquid nitrogen. And now, regardless of the device that you're using or the storage types, you can now introduce your cryo cane or goblet inside the large working area, fill it with liquid nitrogen, and under the level of the liquid nitrogen, you can place the straw inside your cane, and from there transfer it to your storage tank for long-term storage. So the vitrification side, there's a bit of a learning curve, and I would say the most important part of the learning curve is to learn how to place the embryo on the rapid eye. Once you've done that, you've learned that, it's very easy to follow. Now I'm going to introduce or explain to you how to do the warming, and if you think the vitrification was easy, the warming is much easier. So I've already explained to you about our media. When you are ready for your warming, you need to aliquot the appropriate amounts of media, between 0.5 ml and 1 ml of media in our 5-well dishes. Make sure you warm it up. We often get the question, how long should we warm it up for? Now, this is something you need to validate in your own laboratory because it depends on the room temperature that you work in, the temperature of the building, the equipment that you're using. And all of this will have an influence of how long it actually takes for the dish to be equilibrated. Remember that this media contains MOPS, and therefore you should never place it inside a CO2 incubator, either an incubator without CO2 or on a heated stage, just to heat up to 37 degrees Celsius. So when you are ready and you have established that time that you need for the media to warm up, you will take your cane from your dewar, place it inside the smart box that's been filled with liquid nitrogen, and when it's in the box and you have made the security check to make sure it's the right patient that you will be using, we need to open up the device. And for that, we use a very, very simple circular cutting device. We want to make sure that we don't pinch the straws closed, and therefore we use this circular type of cutter. Now, if you, when you inspect the straw, you will see that that black dot that I referred to earlier on the rapid eye is now clearly visible on the straw. And I'm going to cut and open the device just above that black dot. Very important, never cut through the rapid eye, because when you do cut through it, it can send shock waves into this material that could potentially damage the embryo. So always be sure to hold the straw either with your fingers or with a pair of tweezers at that same level, and there you can just lower the cutter over the top and cut it open. So again, here, no stress to the embryos, no stress to the embryologist. We've turned our closed system all of a sudden into an open system. So from here, I'm going to get my dish ready. I'm going to lean in with my very fine tweezers. And like I've done now, I've cut it a little bit too high, so it's a bit hard to reach. I can just, again, cut it a little bit lower. And now I would reach in with the fine tweezers, and I pick it up until I can hold it with my fingers. Don't handle it with the tweezers. It's a very fine pair of tweezers, so rather take it with your fingers. You don't have to worry about thermoconductivity because your embryo is submerged in liquid nitrogen and the plastic cannot conduct the temperature from your fingers. And from here, in one very, very quick movement, you go straight into your first warming solution. And because the embryo is not attached to any surface, you move it around and there it is. It will just fall away from the rapid eye. It's very easy in that sense because the solid vitrified state will all of a sudden turn into liquid. And as soon as it turns into liquid, it literally just falls off the device. So you don't have to use a pipette to move it or remove it from the device. And then from here, you follow the very simple steps for warming. And depending on the type of embryo or blastocyst that you will be warming, you follow that specific protocol. Again, our protocol is optimized for working at 37 degrees Celsius. And because of the higher temperature we work at, we need a lot less time for the actual equilibration to take place. And that way we save a lot of time when we do this type of warming with the vitrification device. So once you've taken it through the 3 steps of warming, you can then place it in your culture dish or your embryo transfer dish, and your embryo will be ready for culture or transfer depending on what it was earmarked for. And that's it. If you want to get some more information on the protocol, on the equipment, the media, please feel free to visit the stand here. And there's some of our clinical support people and salespeople who can give you a lot more information on that. Do you have any questions for me about vitrification? Not today? Good. Thank you for joining.